Hey space explorers, and welcome back to our channel. Have you ever looked up at the night sky and wondered, where does it all end? Not the universe, but our own cosmic backyard, the solar system. Today we're embarking on an epic journey to answer that very question. We're traveling to the edge of the solar system, a place far more strange and mysterious than you might imagine. So buckle up, because we're about to push the boundaries of known space. Our first stop on this grand tour is just beyond the orbit of Neptune, the last of the giant planets. Here we enter a region known as the Kuiper Belt. Think of it as a massive cosmic junkyard, a donut-shaped ring of icy bodies left over from the formation of the solar system. It starts at around 30 astronomical units, or AU, from the Sun. That's 30 times the distance from the Earth to the Sun, and stretches out to about 50 AU. This isn't an empty void. The Kuiper Belt is home to trillions of objects, from small chunks of ice to dwarf planets. The most famous resident here is, of course, Pluto. For decades, we thought Pluto was the 9th planet, the lonely outpost of our solar system. But in 2006, after discovering many other large objects in this region like Eris, Makemake, and Haumea, the International Astronomical Union reclassified Pluto as a dwarf planet. This decision was controversial, but it highlighted a crucial realization. Pluto wasn't an anomaly, it was the king of a whole new realm of celestial bodies. Our New Horizons spacecraft gave us our first ever close-up look at Pluto and its moon Charon in 2015, revealing a stunningly complex world with nitrogen ice mountains, vast plains, and even a potential subsurface ocean. These discoveries showed us that even in the frigid darkness so far from the Sun, worlds can be geologically active and dynamic, and Pluto is just one of many such worlds out here. The Kuiper Belt is a treasure trove of information about the early solar system, a frozen archive waiting to be read. But our journey doesn't end here. We're going further out. As we leave the main part of the Kuiper Belt behind, we enter a region called the scattered disk. This is where things get really wild. The objects in the scattered disk have been scattered by the gravitational influence of Neptune into highly eccentric and inclined orbits. They swoop in close to Neptune's orbit and then get flung far out into the depths of space, sometimes hundreds of AU away from the Sun. These are the true nomads of our solar system, following long, lonely paths through the dark. Dwarf planets like Eris and Sedna are inhabitants of this chaotic region. Sedna in particular has a mind-bogglingly long orbit, taking over 11,000 years to circle the Sun just once. Its existence hints that something else, something massive, might be lurking even further out, gravitationally herding these distant objects. Now let's keep pushing outward. Our next destination is the theoretical boundary where the Sun's influence begins to wane. This is the heliosphere, a giant magnetic bubble created by the solar wind, a stream of charged particles constantly flowing from the Sun. This bubble protects our solar system from high-energy galactic cosmic rays. The edge of this bubble is called the heliopause. Two of humanity's greatest explorers, the Voyager 1 and Voyager 2 spacecraft, have crossed this boundary. In 2012, Voyager 1 officially entered interstellar space, the space between the stars. Voyager 2 followed suit in 2018. They are the first and only human-made objects to do so. The data they sent back was groundbreaking. They detected a sharp increase in galactic cosmic rays and a dramatic drop in solar wind particles, confirming they had punched through the heliosphere and into the great beyond. Imagine that. These probes, launched in the 1970s, are our silent ambassadors, sailing on an ocean of interstellar plasma. They carry with them golden records, time capsules of Earth's sights and sounds, just in case they ever encounter another civilization on their eternal journey. But have we reached the true edge of the solar system? Not quite. Gravitationally, we're still deep within the Sun's territory. Welcome to the final frontier, the most mysterious and vast region of our solar system, the Oort Cloud. Unlike the flat plane of the planets in the Kuiper Belt, the Oort Cloud is believed to be a gigantic, thick-walled spherical shell of icy bodies completely surrounding our Sun. It is absolutely enormous. Its inner edge is thought to start somewhere between 2,000 and 5,000 AU from the Sun, but its outer edge could extend to 100,000 AU or even further. To put that into perspective, that's nearly a quarter of the way to our nearest stellar neighbor, Proxima Centauri. At this distance, the Sun would appear as just another bright star in the sky. The Oort Cloud is purely theoretical. We've never directly observed an object within it, because they are simply too small, dark, and far away. So why do we think it exists? The answer lies with comets, specifically long-period comets, the ones that take thousands or even millions of years to orbit the Sun. These comets come at us from all directions, not just from the plane of the solar system. This random distribution suggests they originate from a vast spherical reservoir. The idea is that these icy bodies in the Oort Cloud are weakly bound by the Sun's gravity. A slight nudge from a passing star, a galactic tide, or a giant molecular cloud can be enough to disturb their orbits and send them hurtling towards the inner solar system. As they approach the Sun, the ice vaporizes, creating the beautiful tails we recognize as comets. Comets like Hale-Bopp or Hyakutake are visitors from this distant, ghostly realm. They are primordial relics, frozen in time since the birth of our solar system 4.6 billion years ago. So where is the ultimate edge? It's where the Sun's gravitational pull becomes weaker than the pull of the surrounding stars and the Milky Way galaxy itself. This boundary is fuzzy and ill-defined, but it lies somewhere within the vast expanse of the Oort Cloud. Beyond this point, an object is no longer truly part of our solar system. It's set adrift in the galactic ocean. From the bustling Kuiper Belt, through the chaotic scattered disk, past the heliospheric boundary, and into the ghostly Oort Cloud. Our journey to the edge has revealed a solar system far larger and more complex than the 8 planets we're familiar with. These distant realms are not empty voids, but are filled with clues about our origins and the nature of the cosmos. What's next? Future telescopes like the upcoming Vera C. Rubin Observatory will be able to map the outer solar system with unprecedented detail, potentially discovering thousands of new Kuiper Belt objects and maybe even catching a glimpse of an object in the inner Oort Cloud for the first time. The search for the hypothetical Planet 9, a massive planet thought to be shaping the orbits of distant objects, also continues. Finding it would completely rewrite our understanding of the solar system's architecture. Our journey to the edge shows us just how much is still left to discover in our own cosmic neighborhood. The final frontier isn't just out there among distant galaxies, it's right here, in the cold, dark, and beautiful depths of our own solar system. Thank you so much for joining me on this incredible voyage. What part of the outer solar system fascinates you the most? Let me know down in the comments. If you enjoyed this cosmic adventure, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you don't miss our next exploration. Until then, keep looking up.